Good morning, students. So last videos, so we have finished with the relation. Now we will continue today the function. So this also is there in the first year. In first year only, today just on 10 to 15 minutes I will explain the first year portion only. So what is the function? A and B, two non-empty sets. The function f from A to B, AB, B2 non-empty sets, the function f from A to B, which associates some rule or method all the elements of set A of set A, all the elements of set A are associated to A, are associated in the set B, and each element of set A to associated to unique element in set B. All the elements of set A are associated in the set B, and each element of set A is unique element to set. For example, 1, 2, 3, 4, A, B, C, D. So this is the function. What I am doing, all the elements of set A are associated. All the elements of set A are associated to elements of set B. To each element of set A is associated to unique element in set B. If you want whether it is function or not, you check here only. All are associated and all are what? Unique. So this is called function. The function f from A to B is denoted by f from A to B. It's okay. When you start types of function, the function, first you start this one, the function f from A to B is A to B. Okay? The function f from A to B is denoted by f from A to B, or even sometimes f maps A. F maps from A to B. F maps. So this is, it is a function. What is the function? All the elements of set A are associated to elements in the set B, and to each element of set A is associated to unique element in set B. So this is the function. For example, this is the f from A to B. 1, 2, 3, 4, 5. A, B, C. So this is my question, whether it is function or not. This is not a function, because what is the function definition? All the elements of set A are associated. But here 5 belongs to A, but 5 is not associated to any element in set B. 5 belongs to A, 5 is not associated to any element of set B. So this function, the f is not a function from A to B. Even if you take this is for example, okay, all the elements are associated and it is unique elements in set B. Now it is called function. Even you take this is D I am taking. This also function. This also function because here D is there no image, but all see the function means you see the set A only. This is also called function. Then one more example. F from A to B. 1, 2, 3, 4, 5. A, B, C, D. Okay. It is function or not? This is not a function. Why it is not a function? One belongs to set A, but one is associated to two elements. One is associated two elements, A and B. But this is not unique element, unique associated elements. Okay. So one goes to A, one goes to B. So these are not unique elements in the set B. Okay. So this is not a function because one is associated having two images A and B. Okay. This is not a function. Even if just to remove it. This is a function of S function. All are associated and unique. So they are very important. The function F from set A to set B is a rule or method of set A to set. All the elements of set are associated A to B. But what are the two conditions? All are associated and it is unique element in the set. Okay. Then what is the next domain? Codomain and range of a function. Domain, codomain and range of a function. Domain means the set A is called, the elements of set A is called domain and elements of set B is called codomain. Elements of set A is called domain, elements of set B is called codomain. So what is the range? Range is denoted by f of x. All the elements of set B associated by f, some function f, to some elements of set A. So this is for f of. For example, this is 1, 2, 3, 4 and A, B, C, D. Okay, A, B, C, D and E. This is the function f from A to B. So one goes to A and it is a function or not? Yes, this is a function because all are associated and unique. Be carefully, all are associated and unique. This is a function. Now he is asking domain, codomain and what? Range. What is the domain? The set A. Domain of f, domain of f equal to the elements of set A, 1, 2, 3, 4. What is the codomain? Codomain of f is equal to A, B, C, D, okay. The elements of set A is called domain and elements of B is called codomain. These are domain, these are called codomain. Be careful, this is very important. So usually the function problems is very important, domain and codomain. Okay. So this is domain, this is called codomain. So what is the range? All the elements of set B are associated by F, some elements of A. So which one is the image? That is the range only. So A, B, C, D. But this is not image of A. So what is the range? Range of F. Range of F equal to, those are images of some elements A, B, C. Because E is not a range, okay? These are, because F of 1 is A, no? F of 2 is A, F of 3 is B, F of 3 is C, F of 4 is D. So this is the no range, okay? This is the domain, codomain, range. One is the function. The function from set A to set B is F from A to B is denoted. So domain is the first, set A is called domain, set B is called codomain, and what? Range. Usually range is denoted by F of A. F of A, this is called a range of the function, equal to F of X such that X belongs to what? A. This is called range function, okay? Even F of A is called a range, it must be subset of B. A range is subset of B only. Whatever the elements of a range is subset of B only, belongs to set B, okay? So F of A is a subset of B. Even sometime codomain, the codomain, okay, then F of A is subset of B. For example, one, two, three examples I'll explain. For example, let A equal to minus 2, minus 1, 0, 1, 2, and B equal to sets 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. Okay. Defined by the function, defined by the function F of X equal to X square. Write the domain, codomain, and range of F. So very simple, is asking domain, codomain, range. Domain, codomain is no problem, because the set A is called domain, the set A and set B respectively is called domain and codomain. So it is very important range. Range means, so what is here? This is the for set A, this is set B. F from A to B, okay? F from A to B. So what is set A? Minus 2, minus 1, 0, 1, 2. 0, 1, 2, 3, 4, given 5, 0, 0, 1, 2, 3, 4, 5, 6. Now you start X is 1, so F of X equal to X square. Now what is the function? F of A is B. So we will take A, this is B, F of A equal to B. F of A equal to B. Now substituting X is minus 2. So what is the F of minus 2? It is F of minus 2 is 4. F of minus 2 is 4 because minus 2 square. What is F of minus 1? 1 only. F of minus 1 is 1. Substituting F of minus 1 is 1. 0, and the 0 is comes. And 1 is again 1, and 2, what is 4. So this is my question, whether it is function or not. Yes, this is a function because all are associated and we need element in set B. Domain is very simple. Set A is called domain, set B is called codomain. there is no problem, domain and domain. But he's asking question, no problem. No, so domain no mention. But question is there, domain, codomain and range. So what is the range? Range is, those are images. What are the images here? 0, 1, 4. There is 2, 3, 5, 6. There is no image. Okay. So what is the range? Range is equal to range of f equal to 0, 1, 4. So this is the example of domain, codomain and range. Here the most important is called range only. So he is asking, is the function is defined, a is given, b is given, set a is given, set b is given. The function is also defined, f of x is x square. Right, it's the range. Range means you are substituting domain, you will get codomain. So minus 2 is 4, minus 1 is 1, and 0 is 0, 1 is 1, and 2 is 4. There is no that field is 2, 3, 5, 6. So the 0, 1, 4 is the called range. Only I am substituting the set A, minus 2, minus 1, 0, 1, 2. Then another example. Now it's the, now to what is the explain? Domain, codomain and what? Range. Again some types of functions. That is, what is the first one? Constant function. Constant function. What is the constant function? Even it is very important, most useful in the differentiation, continuity and differentiability. And most of problems, continuity and differentiability, using graph only. The graph is the shortcut method. So it's very important. Constant function, function f from R to R. The function f from R to R, f of x equal to c. The function f from R to R, f of x equal to c, is called constant function. What is c? Where c belongs to R. Even x also belongs to R. X is R, c also R. So this is called constant function. So what is the graph? You take x-axis and y-axis. Okay. Even I think this is f of x is c. F of x is c. The line is parallel to x-axis. You remember, my dear students, when it is constant function is there, no, where this line, the line should be parallel to x-axis. The line is parallel to x-axis means, so this is called a line. So you take this is 0 and this is a c. So f of x equal to c. You take distance from 6, f of x is 6 only. Okay, f of x is, this line is parallel to x-axis. Line is parallel to x-axis. The function is called constant function. Even for example, f of x equal to 100 is there. Okay. Even you are told both x and c are belongs to real number. Both are real numbers. Okay. Both are. Even x is 100 only. No change. X is 1. X is 200. X is 300. X is 400. X is 100, x is 1000, 100 only. So this is called a constant function. That is very important. What is the domain? That is very important. Domain is equal to R only. Because you are substituting x is 1, x is 2, x is 3, x is 4, x is 5, x is 6. Even a good example, no? F of x is 10. So you substitute x is any value, but 110 only is the answer. X is even 100 has to substitute x is 100. 10 is the answer. F of 100 is 10 only. So I think it is constant, C belongs to R, but domain is R because you are substituting 1 to real numbers. So what is the range? Can you tell me what is the range? Range. What is the range is equal to, is called C. Now this is nothing but singleton set. What is called? Singleton set. And very important. Sometimes a question in the CET or JEE main, the given function f of x, it is a constant function. So write the what range? The range will be C only because it is singleton set. Okay. So this is called what? A constant function. Followed on? Yes. Line parallel to axis. B important. What is the domain? Domain is a real number and range is C. So it is called singleton set. Then notice the next definition, identity function. What is identity function? Identity function. What is identity function? The function f from this common, okay? The function f from R to R is defined by f of x is x. F of x is x is called identity function. In the place of x you can write C, that is called constant function. This is called identity, and most of students they don't know the identity function. F of x is x. Okay, f of x is x. So when identity function is there now, the line is parallel to x-axis. See what is the graph? What is the graph? The line is passing through the origin. Line is passing through the origin, which is inclined at 45 degree. I think maybe it is this line is f of x is x. What is the slope of the straight line? This is 1, m equal to 1 means theta is 45 degree. So very important, the constant function, it is given constant function that this lies on passes through the origin which is inclined at 45 degree. Okay, this is very important, my dear students. When it is identity function is comes now, that line is passes through the origin which is inclined at 45 degree. Even in physics, chemistry, some problems or comes at graphs. Okay, so that graph will be there. When it passes, you remember y is x. The line is passing through origin. Always the theta is 45 degree. So this is called identity function. Then what is the next? Given identity function, f of x is x. So this is identity function. What is the domain? Domain equal to R. Even the range is also R. No problem. Both domain and range are real number only. Because you take x is any real, y is again extend. Okay. So this is both domain and range is real number. But in constant function, domain real number, but range is singleton set. Okay. This is the second definition. Number 3, modulus. Modulus function. What is the modulus function? The function f from R to R. The function f from R to R is defined by f of x equal to mod x. Is called modulus function. Is called modulus function. Even this is also passes through origin because x is 0, f of is 0. Okay. So what is the graph? The modulus function is graph. See, modulus means there are two, one positive, one negative. This is f of x is x, and another is f of x is minus x. I think this is called 0. So when it is modulus function, f of x is modulus of x, I think this is symmetric about y-axis. This portion will be same only. If it's 2, this is minus 2, totally. This is 1, this is the same length, okay? It is symmetric about y-axis, okay? This is x, this is minus x. This is called modulus function. But modulus function, what is the domain? Domain is equal to R. You are substituting x is domain, x is domain. So what is the range? The range is comes very important. Range is, but 0 is there. So 0 is closed and infinity is open. So this is called 0, infinity is called a range. This is interesting. Even I am repeating. And functions are very important chapter because in any, not only in mathematics, in physics, chemistry, so most of problems, the graph method only. The graph method is shortcut only, okay? So we are not following the range. The range means 0 is including. Now it is infinity. 0 including, that line is up to extends in infinity only. 0, infinity. Domain is R. Range is 0, infinity. So modulus function, it is symmetrical about y-axis. One positive, this is x. Even this problem comes in continuity. Whether f of x is modulus of x is continuity or no. Yes, this is called continuous function. At x is 0. At x is 0, the function is called continuous. But it is not differentiable because it is not smooth curve. It is sharp. It is not sharp. Okay. It is not smooth curve. At 0 is not differentiable function. LH, right hand derivative, left hand derivative, both are not equal, but it is a function. It is a continuous function, but not differentiable at x is 0. Remember, what is the domain? Domain is any real number, and the range is 0, closed and infinity, alpha 0, infinity. So even f of x is equal to mod x. So f of x, this modulus of x can be written as x if x is positive, 0 if x is equal to 0, minus x if x is x less than 0. This is called modulus function. Modulus function can be written as in continuity. Even you take left, right hand derivative, left hand. Even this is the right hand limit, this is the left hand limit, this is a value function. Both are equal, limit exists, all are equal. The function is called continuous, but not differentiable. Why? Because derivative of x 1, derivative of x is 1, derivative of x is minus 1. Right hand derivative is not equal to left hand derivative. It's not differentiable. Okay. Tell me what is modulus is continuous but not differentiable. I teach you. So I explained 3 definitions. One is constant, identity, modulus. Then what is next? Greatest. Number 4. Greatest integer function. Greatest integer functions. Greatest integer functions. The function f from R to R is defined by f of x equal to, this is called greatest integer. This should be less than or what? Equal. Greater than or equal. So this is also a very important definition, greatest integer. Even if you want to draw greatest integer function, even 0, 1, 2, 3, minus 1, 1, 2, minus 1, minus 2, even minus 1, minus 2. What is the greatest integer? This is called step functions. This is called step function. Okay. 0 is, you say this is, next 1 is closed, this is open, this is okay. Next 2 and this is 3. So this is called step function. It is called step function. And what is next here? This is, and next this opposite. This is here 0. And what is next here? Minus 2. So this is called step function. Okay. F of x is modulus of f of x is this symbol, this greatest integer function. For example, here f of x, for example, f of x equal to 1, 2, 3, 0, minus 1, minus 2. What is you want to take 2 also. 1 less than or x, or even 0. 0 you take 0. Well, 2, not this much only, you take this much only. 2, 1, 0, minus 1, minus 1. So what is here? 2 less than x, less than what? 3. 2 is including, but less than 3. 2 less than or equal to x. I told it should be less than or equal. 2 less than or x. 1 less than x, less than what? 2. Now it is 0 less than x, less than what? 1. That what is minus 1 less than x, less than what? 0. Minus 2 less than x, minus. So this is the range. Even if we want to 2 to 3, 2 is equal to 2 and closed. This is closed. Equal to 2 but less than 3. Equal to 1 less than 2. 0 less than 1. Minus 1 less than 2. Minus 2. So this is the greatest integer function. Greatest integer function is less than or equal. Suppose f of x equal to greatest integer function. If sometimes it is equal to n. So what is n? N less than x less than n plus 1. This is very important. When f of x is x, f of x is n. So what is n lies between? N lies between, what is x lies between n to n plus 1. But it is equal, less than or equal. N less than or equal to x, x less than n plus 1. This is called greatest integer. What is n? N is called integer. N is called integer. So this is the greatest. And you will tell me what is the domain entry? Domain is real number. What is called? Domain is real number. And you will tell me what is the range? Range is called integer or I. Domain is equal to range is set or I. I think both are not equal. Okay. In problems, when both are equal, that onto function comes. These are types of functions will be there. So here real number, here what integer. What is the domain of greatest integer? Real number. What is the range of greatest integer? Greatest integer is integers. The range of greatest integer is integer. Then what is the next definition? Signum function. This is definition number 5. What is the first one? Constant function, identity function, modulus function, greatest integer function, then signum function. What is the signum function? The function f from R to R, f of x equal to x by modulus of x. If x not equal to 0, 0, if x equal to 0. So this is called signum function. What is called? Signum function. X not equal to 0, x by modulus of x. Or even this is modulus of x by x. F of x is equal to modulus of x by x, x not equal to 0, 0 if x equal to 0. This is called signum function. It is called signum function. What is the graph of signum function? This is called, this is 0, this is 1, another is minus 1. This is signum function. This is called signum function. F of x is mod x by x if x not equal to 0, 0 if x is 0. Okay, this is signum function. So what is the domain? Domain is real number. Domain is real number. Domain is R. What is the range? This is very important in this. Range equal to -1, 0, 1. These are called range. Even these are also not equal because here -1, 0, 1, here any real number. Is it domain and range are equal? No, this is not equal. Okay, domain is not equal to range. But in constant function, both domain and range are equal. Okay, so domain is R, range is -1 and 0, 1. This is called signum function. What is the signum function is defined? F of x equal to modulus of x by x, x not equal to 0 and 0 if x is 0. You are know what is the domain? Domain is any real number. So your domain is any real number. But your answer is 1, -1, 0. This much only. When you take any values of x, any real value of number you take. But these they are fixed 1, -1, 0. So these are called range. So range and not equal to domain. So all of mapping I am taking f from R to R. So what is the next? Even signum function also can be written as, I told what is order. Even x is greater than 0, 1 if x is greater than 0, 0 if x is 0, -1 if x is less than 0. This is also called signum function. But here also limit is not, does not exist, because the right limit 1 is the left limit minus 1. Even this is not differentiable, because here 1 0. Maybe it is differentiation, okay? But it is not continuity, because the left hand not equal to right hand. It's called Signum function. Then what is the next, sixth definition? Another sixth definition, reciprocal. What is called reciprocal function. A reciprocal function. Reciprocal function, the function f from R to R is defined by f of x equal to 1 by x. Yes, the function f from R to R defined by f of x is 1 by x is called a reciprocal function. It is called a reciprocal function. So reciprocal function, what is the graph here? Okay, x is 1. I think x is 0, it comes infinity. Okay, so x is 1, this is comes 1 comma 1. X is minus 1, minus 1 comma minus 1. This is, and this is the graph. Okay, so this is this. So this is called reciprocal function. F of x is 1 by x. Even I am taking here 1 comma 1, here I am taking minus 1 comma minus 1. Okay, maybe it is 0 is not possible here, 0 is not included other than 0. So anyway, tell me, this is called reciprocal function. This is called reciprocal function. Right, so let us take this. Okay, these two, I think it is symmetric. Symmetric what? Symmetric about axis, not comes about y axis. It is symmetric about opposite quadrant. Opposite quadrant. This is third quadrant, this is first quadrant. Opposite. Third is opposite first. No. So this is a symmetric function. Opposite quadrant. Okay. Even this is also called a rectangular hyperbola. What is called? Rectangular hyperbola. Be carefully get to these words. Rectangular hyperbola. Rectangular hyperbola. These are called rectangular hyperbola. The rectangular hyperbola with the chords up to infinity. So these are not touching these two altogether, or not together, altogether. So asymptotes means these are lines are extends up to what? Infinity. Here right limiter, this is the left, extends to infinity. Okay, so these are infinities goes on. Okay, so this is called what is a rectangular hyperbola. So this is symmetric about opposite quadrant. Symmetrical about opposite quadrant. But what is the domain? Anybody tell what is the domain? Domain and range both are same. Domain and range is equal to R other than 0. Very important. Domain and range of this function are other than what? 0. See the graph, 0 is not there. But start from 1 only. X is 1, x is 0, what happens? It goes to infinity. So I think domain and range of the reciprocal function other than 0 are other than 0 is domain and range. This is called a reciprocal function. Now what is next? Seventh definition, number 7. exponential function. What is called exponential? Exponential function. The function f from R to R is said to be exponential function. The function f of x is a raised to x. The function f from R to R is defined by f of x is equal to a raised to x. Is called exponential function. What is called exponential function? What is the condition? A is positive and a not equal to 1. These are conditions. A positive but a not equal to 1. This is called exponential function. See how it is comes graph. The graph will comes, see, so x is 0. X0 means what is f of x? 1. I think this is called 1 comma 0. This is called 1 comma 0. So this is the graph. I think this is a raised to x, a greater than what? 1. And one more it is comes here. This is called a raised to x if a less than 1. Even 0 less than a less than 1. So this is the graph of, this is 1 comma 0. This is also called, I think this graph a raised to x, this graph a raised to x, a greater than 1, and this is a less than 1. This is called exponential function. In exponential function, what is the domain? Domain equal to any real number. So what is the range? Range is equal to what is answer? Anybody tell me? Yes, it is called 0 comma infinity. Yes, this is also important. So this is called exponential function. I told many problems are there using graphs only. When you want exponential functions, if you want graph, so this is the graph of exponential function. Only a raised to x a greater than 1 means this also. If you want, it is separate if you want. Both are intersected at 1 comma 0 because x is 1, so y is x 0, sorry. It is 0 comma 1 only, not this is 1 comma 0. So 0 comma 1, x 0 and y will be 1, 0 comma 1. So this is called exponential function. Okay, sorry, it's not 1 comma 0, this is called 0 comma 1. What is the name of the graph? Is called exponential graph. What is the domain of the exponential function? A real number and range is 0 comma infinity. Okay, 0 comma infinity. Even for example, f of x is equal to 2 raised to x, f of x is equal to 3 raised to x, f of x is 4 raised to x. So I want to graph of these functions. So graph of this only x is equal, this is the graph. I think x is 0, I think it is, this is the 1, another one is this, another one is this, because all are intersected where 0 comma 1 only, because x 0. So this is called 2 raised to x, this is called 3 raised to x, this is called 4 raised to x. But what is this point? So 0 comma 1, x 0, so y is 1 only. I think 0 comma 1 is the, so this is the graph. but only positive. When you take this negative, this side comes. Okay, so this is called exponential function. So one more definition is, it is called logarithmic function. What is called? Logarithm. This is called logarithm functions. The function f from R to R defined by f of x equal to log x to the base a in general. So this is called logarithmic differentiation. Logarithm function. So how this comes graph here? The graph is very important. X may be positive. X not negative. X is positive. Even a is x log x to the base a. X a positive and a is not equal to 1. Even a is positive and a is not equal to 1. X is, this is the logarithm function. So how it starts the logarithm function? X is 1, log 1, what is answer? 0. I think this is called 1 comma 0. This is the graph. This is 1 comma 0. Another is, this is the called logarithm function. This is one one, this is another. But both are intersect what? 1 comma 0 1. Then what about this is? This is positive. This is the positive. This is negative. So this is called a greater than 1. This is a greater than 1. This is a less than 1. And previous one, exponential function, where it is means 0 comma 1 means. Here 1 comma 0. Anybody tell me what is the domain here? Domain is equal to 0 comma infinity. Domain is 0 comma infinity. The range is equal to R. Very, very important. In this graph you see 1 comma 0, 2 comma 0, 1 comma 0. So I think it is 0 comma infinity is the domain and range is R. You have substituting x is any positive number and his what is range is real number. Okay. 0 comma infinity is domain and range is R.